Hello, this is Amy with Amy Astro. I'm back with the next video in the How to Use PixInsight series. Thank you for watching. If you like this video, please subscribe below, like and share this video with your friends, and follow me on Facebook as Amy Astro, where I share my astro imaging adventures and answer questions. In this video, we will start processing our light frames and work towards a single image on each filter. So let's continue editing our elephant nebula. Remember, we're going to start with opening up our template project that we made a couple videos ago, and it's in my open recent project files, and there it is. And all my processes open up for me. Now, if you remember in a previous video, we created our master dark file, our super bias, and we have calibrated all of our flat files. So now what's left is for us to calibrate and approve and register all these other files. So let's get started. Let's do image calibration. Let's add some files. Let's go after our hydrogen alpha. There they are. And open. And let's find an output directory. It's never that easy to find the directory the first time. There they are. And we're going to put them in the calibrated folder. Okay. So we are going to add our master bias. So we'll go for that one. It's in our calibration directory. And there's our super bias. All these images were taken at 300 seconds or 5 minutes. So we're going to grab our master dark that we created for a 5-minute photo. Open. And we will leave all these the same. And let's go ahead and get our master flat in there. And this is hydrogen alpha. So flat HA. Open. Okay, that's everything we need to do. Everything else is just the default settings. And let's run. As you can see, as they're calibrating, they are dropping over here in our directory, and it's all getting populated for us. Okay, that's all done. Let's clear this out. And minimize this. Oops. So our next step will be our cosmetic correction. We'll open that window. We will add the files. And right now our goal is to get rid of all the white hot spots that are in our images. So let's go to hydrogen alpha, the calibrated files, and we'll grab them. Notice they all end with an underbar C saying they've been calibrated. And we'll open. Output directory should be the hydrogen alpha with the cosmetic correction at the end. And open. And we need to add a master dark file. This is for it to compare against. Calibration and our master dark. Okay. Now let's push this over here. Let's double click on one of these images to open it. Make them bigger. Let's give them a stretch. This is what one image looks like, but we're trying to get rid of all the hot pixels. So we need to choose a section of this photo that has no stars and no nebulosity. So it's probably going to be up here in this corner. So I'm going to zoom in and get us over there. That top corner. Okay, and now I'm going to take this button right here, which is a new preview mode, and I'm going to select it. And I am going to draw myself a square, but don't include any stars. And there's my preview. So right here we're going to open up our preview, and you notice he's really tiny. That's okay. Let's hit the zoom button and zoom in as far as we can. Now we can see all the little pixels there. And we're going to say live view, please. And I'm going to make this bigger just so I can see what's going on. There we go. Enable hot pixels and enable cold pixels. Usually there's not that many. It knows I've got about 13. And what you do is you take this sigma sliding bar and you slide it all the way down, and if you watch our image over there, you're going to notice the really bright spots are going to slowly start to disappear. There's one that went away. And I typically take this about 2.5 to 3, but you don't want to go too carried away because you don't want to remove the good stuff. So I just go slowly and see what pops in and what pops out. And it's kind of a judgment call. There's no right or wrong. If you take out too many little pixels, you will notice. So you just rerun this at a different number. But I'm going to say that looks about right. And let's the original and after I cosmetic correction. You see which pixels I dropped out and made them darker? There we go. So all I have to do now is run it. Alright, 17 succeeded. That one's a little pretty quick. Let's close this preview window out and let's close the file altogether. We don't need it anymore. And I'm going to clear these out and say OK. The next step, here, look back at our directory structure, that always helps us. Cosmetic correction with the CC, they have been done. So the next thing we want to do is approve all these images. So I'm not able to keep the approval process open. It doesn't like to stay open, so you just have to remember where it's at. It is a script. It's under batch processing and it's called subframe selector. Clear these out. First thing we're going to do is add all of our files. We'll go back to those cosmetically corrected files we just created. We're going to grab all of those. Say open. Okay. Now this is where you're going to have to do a little research on your camera. Right now, my camera has 1.38 arc seconds per pixels, and you can get this from your camera manufacturer. It is the scale, and the camera resolution is 12-bit. This we generally keep as 1, and it's 24 hours in a day, and then I leave these as they came in alone. Now let me show you where you can also get that 1.38 information from. Alright, here's a screenshot that I took from astronomy.tools online, and this is a great little website. Always keep this in your little favorites. So we've got 3 modes. You got visual mode, imaging mode, and binocular mode. We're going to go under imaging mode because we're taking pictures. In this drop down you have a whole bunch of telescopes listed. You go find your telescope, and same here, you find your camera. I use a point X reducer, and these numbers auto-populate for me. And I didn't do any binning. And I like to go up here and grab the Andromeda galaxy because I know how it should fit in my camera. And then I'll come back here and say add to view. And it will show me what my camera can take of Andromeda. It kind of clips the edges some. But right through here, this resolution is also known as my scale. And that scale is in right here. Let me show you another spot. Okay, this is from my camera manufacturer. And you can see the camera manufacturer says 456 by 3520. It's the same thing that auto-populated here. So if your telescope is not in this list, it's okay. Just go find your telescope or go find your camera from your manufacturer and just manually type in this little bits of details. See, there's 1 pixels. And let's see, we got another one here. Open up the telescope, and the telescope is 102 millimeters, which is the aperture. My focal length is 714, which is 714. So you can fill all this in just from the camera manufacturer stuff. Alright, so let's get back to this one. I leave these at default values. Expressions. Okay, you do not have to fill this in. This is me letting the computer kind of help me with what I want to choose. And what it is it's looking at the photos and it's looking at the full weight half measure. I want it to be less than 6, and I want the eccentricity to be less than 7.1. Now, the eccentricity is the roundness of your stars. So at a 0.4, you have a near perfect star. Almost impossible to accomplish unless you have really high-end gear. So I am telling this, once I get to 0.72, I have some real elongated stars, and those are just photos I don't want in my collection. And there are times I get even pickier and I'll drop this down to 0.6. But if the night isn't really good, I'll go ahead and let the 0.71 slide through. And my weighting is called SNR weight. So here we are, we've got all of our images loaded up. The table will auto-populate after it measures things. Let's go here to the output. Let's find our directory we want to put everything in. Let's go right here. I'm going to drop them in there. Now this is a two-step process here. Remember this keyword here, this weight keyword, you must fill it in as SS weight. It will help you in the end. I'm going to shrink that up. Okay, step one is we've got to measure everything. And we'll come back once it's done measuring. Alright, so this process is done running. Let's go ahead and close this up just a little bit and show you what's going on. Okay. So here's the results of it, analyzing all my photos. It puts them in an order. I have them sorted by eccentricity, but you can sort them by whatever number you feel comfortable with recognizing. I choose this because I know that this means long stars. So my smallest star is 0.54, that's pretty darn good. And then it gets progressively worse at 0.68, which still is pretty good. I had all 17 of 17 images were approved. That hardly ever happens, so don't feel bad if you start losing 20-30% of your images. That's why we take so many. Okay, and right here our full weight half measure. It weights my stars, and as long as this number stays under 6, I'm happy. Okay, so let's look at what it looks like plotted out on a graph. You can change your chart here, and we can see that I've got some tiny stars, I got some bigger stars, and if I had something that was just way out there and I didn't like it, even though it said it was okay, I can always go through here and click a button, and that becomes an X. And if I look in this table, one of these is going to be unchecked now, and he got dropped out. If I change my mind, I click them again and let them back in. Or I can uncheck them here or check them back, whatever you like. See, it selected everything for me because I put this formula in. If you don't put a formula in, you're going to have to manually select the images that you want to keep. And typically it's the outliers on a graph. So we can look at the weight. It's kind of an unusual curve. And let's see. There's the full weight half measure number. But again, I just stick with eccentricity because I just want to know if my stars are round. Okay, we're going to output them to our approved folder. And remember to have the keyword of SS weight because you're going to need that when it comes time to integrate everything. We're going to copy all the images over there. Now, if it was an image that was not selected, it just won't get copied over to the approval directory. It helps you kind of weed things out. So now step 2 is we've got to output the subframes, and this takes a little bit longer. Alright, so now that that's done, I don't usually hit the reset button here because I don't want to retype that expression every time. So I just hit dismiss and say yes, I really want to dismiss it. And now I don't have to fill in any of those things next time I use the subframe selector. So let's look at our finder again. We have all of these were just approved. So the next step is we need to register them. But the thing is with registration is we only want to register all of these files one time. because if you start doing them multiple times, if I register these guys against one of here, and I register these against one of the guys in here, then you're starting to add more artifacts and noise and distortion to your images. And this was a tip that I learned from a comment on a previous video, so that was a great tip to learn. So that tip came out of a book, and it's called Inside PixInsight, and it's by Warren A. Keller, and I purchased this off of Amazon. Nice little softback book, glossy photos and all. And I have the second edition here. And if you turn to page 52 in the second edition, there's a section called Helpful Hints, and it will explain to you why you only want to register all of your files once. So with my directory structure, it makes things a little bit more interesting. We've got to think about this. So when I register all of my images, I'm going to just register them off this first photo. They say to choose the best one out of all of them, but I can honestly never remember which one's the best one, so I can remember what's the first one. So all of my filters, the oxygen and the sulfur, will be registered against this one file. All right, so let's get started on that part. Okay, to register our files, that's called star alignment. And we're going to choose a file, and we're going to choose that first one in the hydrogen alpha directory. And that's this one right here under approved and number 1. Okay, and we want to generate drizzle data. All these I leave as defaults. And let's add our files. I'm going to add all those. Say open. Let's give it an output directory. And that'll be this one right here, the registered, normaled, and drizzled. And let's see. Star detection, I leave these as defaults. If things don't align, then you may want to bump up this number just a little bit. Usually images that don't have a real heavy star field, they struggle to align. The one that I have the biggest trouble aligning is the Whirlpool Galaxy. I don't know why, but that one always gives me fits. So I will take this ransack and I will jack him all the way up to allow more items to be selected. But for right now, I'm not overly worried about that, so we'll just leave it at a number. It doesn't matter. And let's run. And if we're lucky, 17 out of 17 will align. And here, 17 aligned, perfect. That's exactly what you want to see, because once you've gone through that approval process, really all of them should align. Okay, so let's clear this out and minimize them. The next thing we're going to do is local normalization. You notice I've got them in order here, makes things really nice. Okay, bring it down. Now the file, that's going to be the hydrogen alpha file. Let's go to what we just registered. Let's choose the first one. Notice I've got this drizzled file in here, and then this is our regular file. Just choose the first file. Just remember I said, after a while I can't remember which one of those were the best, so I just stick with the first one and say open. And I leave all of these the same, but I make sure that I check this and say generate normalization data. Now I've seen some people take this number up to 256. I haven't really noticed a huge difference in them, so I just leave it at the default of 128. So let's go and add our files. We're adding the files that we just aligned. And we're going to say open. And let's put them in the directory. See right here, we just registered them, and we're going to put them in the normalized directory hall. So this one directory is going to get a little bit full, but we want them all in the same directory. Okay, and let's run. This process takes a little bit of time. All right, we're done normalizing these. All 17 succeeded. That took about 5 minutes to occur. Now, I recently did an image that had about 50 files attached to it. It took a little over an hour, so be patient. Good things do take a little bit of extra time. Okay, so now we are going to clear this out and minimize them. the next step is we are going to, what are we going to do? Oh, it's time to integrate the images. The best part. So let's add our files. This file, notice you've got a drizzle, you've got your regular, and you got your normalization. So we're going to do this in 3 little steps here. Let's grab all the regulars. Did it grab all of them? Open. Now right here we want to add our local normalized files. And you'll notice only those are the ones highlighted, so you can just go and grab all of them and open. And we want to add our drizzle files. And go ahead and open them. And here's all of our files. You notice we've got an N for normalized and D for drizzled, and we should have one of those on every image. And we do. Okay, now here's some fun. Our combination is going to be average. We are going to do local normalization. Our weight is going to be fits keyword. So you've got all of them in the pull down. Fits keyword. Now that keyword is what we put in when we approved our images, and that was SS weight. Okay, we're going to generate an integrated image. We're going to generate our drizzle data. This is another step. Evaluate our noise. Let's close that up. Pixel rejection. Now, I have less than 20, so I can't use linear fit clipping, which is my favorite. So I have more than 10, so I can use this Windsorized Sigma clipping. That is what I'm going to choose. I'll still local normalization. I'm going to generate the rejection map so you can see what they look like. Close that. And I don't change anything here under pixel rejection 2 or 3 or this large scale. They're all defaults. Let's apply this and see what magic appears. Alright, all these images have been integrated. Push this out of the way. Now here's our first rejection. I'm going to make them a little bit bigger for you. Let's give them a stretch. And you see all these little pixels. This is what got rejected. Alright, here's our rejection low. Make them bigger. Give them a good stretch. And you see all of these, let's zoom in just a little bit. All those little dots, and they got rejected too. Well, let's see what we're left with. Beautiful. That's our hydrogen alpha stacked image. So that's exactly what I wanted to see. I've got the elephant trunk here and everything else all around him. And let's take a look at our stars. Let's zoom in just a little bit. And I have nice round stars. Doesn't get any better than this, guys. Alright, so here's what I'm going to do next. I'm going to go ahead and process the oxygen. I will calibrate them, cosmetic correct them, and approve them. And the next time you see me come back here, I'm going to be ready to register them. And that's where I'm going to pick up. Everything else is going to be the same steps we've done before. So I'll be back in just a few minutes. The oxygen have been done through the approval process. So now we need to come back and do the registration. Now this is what I want you to notice. It's very important. That's why I wanted to show you the oxygen. This is my first hydrogen alpha one that I did, that I registered the first group with. So we want to use that for oxygen. Leave all these other settings the same. Let's go add our oxygen files. And let's put them in the oxygen directory. Everything else is the same. And we'll apply global. So when it comes time for me to do the sulfur images, I will still maintain the same hydrogen alpha file up here to align against. So everything is aligned against the exact same file, so you only register everything technically once. So star alignment is complete. I have 12 images and they all align together nicely. Let's clear this and minimize that. Now the local normalization. This is what I want you to pay attention to. I'm not going to local normalize against the hydrogen alpha. I've tried this, it makes a mess of things. So what I need to normalize against is my oxygen. So I'm just going to grab the first image in the oxygen group and open, and that's what I'm going to normalize against. Let's add all of the oxygen in here and open. And let's put them in the correct directory. It's the oxygen, open, and we will run this. Now when I tried to do a local normalization all on the same hydrogen alpha file, they all came out like mush. That's why I'm saying don't do it. Local normalization needs to be done against its own filter. Alright, the images have all been local normalized. Let's clear these out. And now let's go ahead and integrate our oxygen. Let's clear these from the last time. Let's go in and add all of our oxygen. These are our main images. Add our local normalized files. And let's add our drizzle files. And open. Okay, I have 12 images here. So I still qualify for the Windsorized Sigma clipping. We will run that. So once we do all of these, I'll come back and we'll go back to the hydrogen alpha image and we're going to run the drizzleization on it. I just wanted to show you the difference in star aligning the next filter in your train. Alright, let's take a peek at these. These are our rejection high. All that's gotten is removed from the image. I'll close that. Let's see what our rejection low looks like. There's some pixels there. Let's get rid of those. And this is what our oxygen looks like. Not bad at all. It's got good detail. And let's zoom in and take a peek at those stars. They look pretty round to me. So I'm happy with that. I'll just minimize that. You know what? I'm getting lazy. Let's change the identifier of that. I'm just going to put O for right now. So I remember that one's oxygen, because at some point they start looking similar. Of course, nobody can mistake the hydrogen. And let's, oops. Mouse is possessed. Right mouse identifier, and let's just call that H for right now. Okay. So now we need to do the drizzle integration process on the hydrogen alpha photo. So let's add files. Let's go back to our hydrogen alpha. And it's this directory right here, the last one. That's what the drizz stands for. Let's grab all the drizz and open. And we need to add the normalized. And they're all highlighted for us. So you grab those too. And open. Okay, I leave all this as default. Enable pixel rejection, enable image weighting, enable surface splines, enable local normalization. These are all just the defaults and I leave them there. And apply global. Alright, our drizzle is done. That took a pretty long time. I'll have to look up the time on that, but it felt like a good 10 or 15 minutes. I'm going to clear these and minimize this out of the way. And this is what the drizzled weights looks like when you first get it. But let's take a peek at it with the stretch. And you can see these are the little droppings that it decided to clean up. Almost looks like fingerprints somewhere. But all of this will help improve your photo by getting rid of these impurities. Let's close that. And this is what our image will end up looking like. Now when you compare the two, you're not going to see an enormous change, but every little bit helps. So this top one is our drizzled one, the bottom one is the other one. will just go ahead and identify it. This is going to be my new hydrogen alpha photo. And I will do a file, save as to it. And let's put it in the correct directory. Oh, missing a folder here. Let's add a new folder and let's call this stack. And we'll drop it in there. And I will minimize him. And this original hydrogen alpha, I don't keep him. I just get rid of him. Okay, so what I need to do still is I need to do the oxygen and run it through the drizzle. And then I'm going to take the sulfur all the way through until I get a single image, and then I'll be right back. Here are our three final images. We've got our hydrogen alpha here. We've got our oxygen. Not a whole lot of data showing up there, but every little bit helps. And here is our sulfur, just a little bit of data here. Now, if I took a stack of these with a bunch more photos, you would get more information. But with stacks of only 12 to 15, this really isn't too bad. So in our next video, we're going to come back to this very spot and we will edit the pictures down to a single image, and we will process it all the way through. I hope you enjoyed this video. If you would, please subscribe and like this video and tell all your friends about Amy Astro. Follow me on Facebook as Amy Astro, where I answer people's questions and I offer you up new tips and tricks. I do appreciate your time. Until the next time, clear skies.